Hi, I'm Nicole.
Hi, I'm Mimi.
Hi, I'm Natalie.
Hi, I'm Devin, and today we are going to be talking about the IR spectroscopy and the greenhouse effect.
What is the greenhouse effect, you ask? Well, it is when heat is trapped by gas in the atmosphere. This keeps the Earth warm. The gases in our atmosphere help control the Earth's temperature, and these gases are known as the greenhouse gases. The three most common greenhouse gases include carbon dioxide, water, and methane.
The greenhouse effect has kept the atmospheric temperature at an average of about 15 degrees Celsius or 59 degrees Fahrenheit in order for life to evolve. The sun emits energy in the form of sunlight, which is absorbed on Earth by the land and water. The energy that is absorbed warms up the Earth as well as ourselves. The heat that's given off from sunlight is the type of energy that is called infrared radiation.
Infrared radiation is a type of electromagnetic radiation. Infrared light is part of the electromagnetic spectrum that people encounter most in everyday life, although much of it goes unnoticed. Some of that infrared radiation can also be absorbed by the greenhouse gases and clouds in the atmosphere, releasing it in all directions, even back inside the atmosphere.
The greenhouse gases and the sun are needed to sustain life on Earth. Greenhouse gases are essential, but on the other hand, too much greenhouse gases in the atmosphere will result in a big problem. Human activities can cause this problem because we add these gases with our daily routines, which means less infrared radiation leaves the atmosphere. Oh no.
For instance, when we drive a car, work in a factory, or even use electricity, we require the use of energy. This energy comes from burning fossil fuels like oil, gas, and coal, which produces carbon dioxide. Because of this, humans create more greenhouse gases, and with an increased amount of these gases, more heat is trapped and our planet gets increasingly warmer. The warmer temperature affects our planet by changing the climate.
For example, it can change the rain and snow patterns, create a higher sea level, melt glaciers, and create droughts. The infrared radiation and the greenhouse effect is a part of the electromagnetic spectrum. So, to understand the greenhouse effect, we need to get a better understanding of the infrared absorptions on the electromagnetic spectrum.
Looking at the electromagnetic spectrum, we see that the frequency is measured in hertz and the wavelength is measured in meters. The infrared section is roughly in the middle with a frequency of around 10 to the 12 hertz and a wavelength of 10 to the negative 5 meters. As we move to the left side of the infrared region, we encounter microwaves and radio waves. On the other hand, if we move to the right side, we will encounter visible, ultraviolet, and X-rays. Frequency and wavelength are interchangeable and can be represented in this equation where lambda is the wavelength, nu is the frequency, and c is the speed of light.
This electromagnetic spectrum relates the regions to which type of transition it observes. The microwave region observes rotational transitions, the infrared region observes vibrational transitions, and the visible region observes the electronic transitions. We can see that the nuclear region is higher in energy, whereas the radio wave region is lower in energy.
Looking at a diatomic molecule, the harmonic oscillator system can explain the infrared radiation. The energy for the harmonic oscillator is calculated using this energy equation on the bottom left. EV is the energy, h bar is Planck's constant, h is the force constant, mu is the reduced mass for the diatomic molecule, and mu is the frequency. We can reduce this energy equation to a simpler form by replacing the k divided by mu raised to the 1/2 power with omega. Then it becomes the equation on the bottom right corner. This equation determines the energy for each level, but it is known that the spacing between each level for the harmonic oscillator remains the same as h bar omega. These energy levels are quantized, which plays a role in IR absorption.
In terms of quantum mechanics, a gas molecule absorbs radiation of a given wavelength only if the energy will increase the internal energy level of the molecule. This internal energy level is quantized in a series of electronic, vibrational, and rotational states. Transitioning to a higher state increases the internal energy. Vibrational transitions are reflected in the infrared region, and in the rotational transitions are reflected in the microwave region.
The gases that are absorbed range from 5 to 50 millimeters and are the greenhouse gases. The absorptions correspond to the vibrational and rotational transitions. The selection rule from quantum mechanics states that the vibrational transitions are only allowed if the change in the vibrational state changes the dipole of the molecule. The vibrational states represent different degrees of stretching or flexing of the molecule. The molecules that acquire a charge asymmetrically by stretching or flexing are carbon dioxide, water, dinitrogen monoxide, and ozone. These are the greenhouse gases because the dipole changes. This is the example of carbon monoxide and its vibrational modes.
Overall, the greenhouse gases are IR active and continuously become trapped in the Earth's atmosphere.
This rate is increasing even faster as humans help create more greenhouse gases by doing everyday activities. This is what causes global warming.
Quantum mechanics help us understand the infrared region of the spectrum, which tells us about the greenhouse gases.
In conclusion, the increased greenhouse gases will continue to move, which will cause an increase in the Earth's temperature that can result in major changes.
Thank you for watching.
Why the bike save the world?